My name is Kyle Miller. I'm a student in the online Masters of Science program at Georgia Tech. I'd like to present an overview of my research project for CSE8803 Big Data for Health Informatics entitled Similarity in Clustering Using Graph Processing for ICU Patient Mortality Modeling. The motivations for this project are threefold: data availability, technology availability, and a desire to use technical skills to improve outcomes in a healthcare setting. The MIMIC2 database is a freely available, with approved training and data use agreement, collection of de-identified intensive care unit patient information collected from a variety of hospitals over the course of 7 years. This data has been the source for a significant number of studies and has since been replaced by a newer collection of data in MIMIC3. However, for this project, I chose to use the MIMIC2 database in order to closely parallel some existing research by Gassemi et al., which can be found in the references section of my paper. Apache Spark is an open source engine for large-scale data processing. On their website, they claim to be up to 100 times faster than Hadoop. It has hooks for several popular programming languages, including Scala, and scripts that help spin up clusters in Amazon Web Services. Spark's availability and maturity as a platform made it a good fit to explore the MIMIC2 dataset. The final motivation for this project is personal. I am a computer scientist and my wife is a physician. I have always been fascinated by how our worlds intersect. As the number of my wife's patient interactions have increased, I've seen how she pulls on her experience to guide her care of current patients. As a computer scientist with an interest in big data, I cannot help but think of how technology could bolster her or any physician's ability to practice medicine by using computational tools and a larger patient record set. The technical approach for this project was fairly straightforward and accomplished with less than 1,000 lines of code written. First, I downloaded the MIMIC2 database via gzip tar files. I extracted them locally and ran a utility to import them into my Max instance of Postgres. I then used a SQL context in Spark to gather data from the tables and views I was interested in into resilient distributed datasets, or RDDs, which were the primary data structure for my operations. I filtered the RDDs using a combination of SQL joins and Spark operations to create sets of patients, lab results, medications that were taken, SAPS-1 scores, which are an indication of patient status, and comorbidities. With those RDDs, I created a graph containing vertices of each unique patient, lab, medication, and comorbidity, and edges between each patient and their labs run, medications given, SAP scores, and comorbidities present. Using this graph, I calculated the Jacquard similarity between each patient. My intent was to use the similarities to find clusters of patients using power iteration clustering, and then measure cluster purity and refine feature definition iteratively over the results. Unfortunately, I was not able to complete the clustering step, which prevented the completion of my results. I describe this in more detail in the accompanying paper. The preliminary product of my work is a graph of patient similarities. The Jacquard similarity of each patient was calculated with respect to all other patients in the dataset. The histogram on the left shows the counts of each similarity score bucketed into ranges of 1/10. If you exclude bucket 0, which contains similarities between 0.0 and 0.1, the distribution appears to be normal, as can be seen in the histogram on the right. The raw data, as shown in the left histogram, has a count of 429,201, a mean of 0.198824, and a standard deviation of 0.225738. If you exclude the entire first bucket, as shown in the right histogram, the count drops to 200,144, with a mean of 0.419934 and a standard deviation of 0.132195. Sometimes, if you can't serve as an example, you can at least serve as a warning to others. As detailed in the accompanying paper, there were several technical hurdles that I was unable to overcome in order to complete my research. However, in the process of working with Spark, I was able to find and resolve some issues that may help others in the future. There are about 537,000 Google results for the phrase "Spark, no space left on device," which is one of the errors I was seeing. I was not able to find the solution to my problem in the first several pages of results, so I created a blog post describing the solution that worked for me. Additionally, I created a blog post about how to configure persistent HDFS for Spark's clusters built using Spark's EC2 scripts, as well as some tips on memory tuning and garbage collection. The links to these posts can be found in the appendix of the accompanying paper. It is my hope that even though my research objective failed, The byproducts of my efforts may be useful to someone else in theirs. Thank you for your attention.